Here's a wave that repeats, and here's another wave that repeats. Add them, and you'd expect the answer to repeat too. It does, but not until 42 samples have gone by. Change one number, and it never repeats again. Ever. This is question 1 on your digital signal analysis paper almost every year. 6 marks, and most people give half of them away. Because nobody tells you this clearly, in discrete time, a sine wave might not be periodic at all. In continuous time, you have the whole curve. Every value of t is fair game, so the shape always comes back around, always. But discrete time only lets you stand on the integers. You get these samples, nothing in between, and that changes everything. To repeat, you need a whole number n, where the pattern lines up exactly, which means the angle must advance by a whole number of full turns. Omega times n equals 2 pi times k, with n and k both integers. Rearrange it, and you get the only test you'll ever need. 2 pi over omega has to be rational, a ratio of 2 whole numbers. That's the entire rule. Everything after this is arithmetic. So, take cosine of n, plain, ordinary cosine of n. Omega is 1, so 2 pi over omega is just 2 pi. And 2 pi is irrational. It is not a ratio of whole numbers. So this never repeats, not after 10 samples, not after a billion. The samples walk around the circle forever and never land twice. In continuous time, that same cosine repeats perfectly. Sampling broke it. Now, the real question. Cosine of 2 pi n over 7 plus sine of pi n over 3. Take each piece alone. For the first, omega is 2 pi over 7. 2 pi divided by that is exactly 7, so n1 is 7. For the second, omega is pi over 3, and 2 pi over that is 6. So n2 is 6. Both pieces are periodic. That was the easy half. Here's where the marks disappear. The sum does not repeat at 7 or at 6. It repeats when both repeat together. That's the least common multiple. LCM of 7 and 6 is 42. The fundamental period is 42. And nothing smaller works. I checked all 41. 42 really is the first. Now, change one digit. Make the second term sine of 3n over 5. Omega is 3/5, so 2 pi over omega is 10 pi over 3. P is irrational, so that's irrational, so that term never repeats. And one non-repeating term poisons the whole sum. One digit did that. Part 2 of the same question. Energy signal or power signal. Energy is the total of the magnitude squared, summed over all n. Power is that same sum, averaged over a window as the window grows. A decaying exponential dies out, so its total is finite. Energy signal. Its average power is 0, because that finite energy is spread over infinite time. A sine wave runs forever, infinite energy but finite power. Power signal. So finite energy means 0 power. Finite power means infinite energy. No signal is ever both, and that alone is usually worth a mark. Part 3 switches to the system. 4 properties, 4 fast tests. Memoryless. Does the output at time n use only the input at time n? Causal. Does it ever peak at future inputs? If so, you cannot build it. Time invariant. Delay the input and the output should only be delayed. Stable. Sum the magnitudes of the impulse response. Finite sum. Stable system. Try a real one. Y of n equals x of n plus e squared times y of n minus 1. That feedback coefficient is about 7.4, bigger than 1. Every trip around the loop multiplies by 7.4. The output explodes. Not stable, and you can see it in a single line. In continuous time, every sine wave comes home eventually. Sampling takes that promise away. Now you know exactly when it keeps it.